We go.
Okay, welcome to the September 9th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KB0S, and this week I've been doing some antenna work, doing a little bit of uh, reorganizing computers, um, gradually still working on migrating operating systems. I've been very impressed with the new Debian. Okay, next on the list we have Nathaniel, W2NAF. Go ahead.
Thanks, Dave. I've continued to just keep things going on here at the University of Scranton and try to move projects forward. Back to net.
Very good. Next on the list is Dave, KD0EAG. Welcome back.
Well, as I was just saying, I have not accomplished well, I did. I actually worked on some code while I was on my trip. I sat in the hotel looking out over Stockholm and tried to write code, but that's a hard thing to do. Um, Otherwise, it was, but that's pretty much the extent of um, of what I've been up to.
Okay. Next on the list is Clint, K7OEI. Go ahead, Clint.
Let's see here. Okay. Just repairing more RX-888s is the main thing I've done. I did put together a QMX Plus. It's kind of interesting to see something that is nonlinear producing linear waveforms, but the math works out, but it's still cool nonetheless. So back to you.
Oh, very good. Next on the list, we have Dave H, W6OQ. Go ahead.
Good night.
There you go. I'm not getting all of your.
Yeah.
Nope. Okay. Well, next on the list, we have Dave Julian, WB9YIG. Go ahead, Dave.
Yeah, good evening, folks. Not much going on. I went to the Louisville Ham Fest, sold about $800 worth, and got rid of about 500 pounds of stuff. So I'm happy.
Yeah.
That's it.
Well, that's good. Next on the list, we have Elmer N3AGE. Go ahead.
Just checking in. Worked on Nathaniel's station a week ago. That was kind of interesting. I brought my brother up. We did some work up there. So that was what we did.
Very good. And let's see. Next on the list is Jay Schwartz, WB8SBI. Go ahead.
Oh, howdy, everybody. I saw there was an article. Nathaniel, please refresh my memory on this. Our ham radio colleague who's in charge of the MIT Haystack Observatory.
Phil Erickson.
Yeah.
Yes, that there was an article where he was mentioning about VLF propagation, that it actually can go up to the inner edge of the um, uh,
Ionosphere.
no, not the, it goes beyond that. The Okay, I'm having another senior citizen moment here. The radiation belt, Van Allen belt, it can actually go up there. That there's some research that those signals actually will go up there and can affect the Van Allen belt in some way. Now, this would be on the edge of the Van Allen belt that's facing the Earth. And the amount of power it takes a VLF signal to get up there is significant. So just amateur radio power is not going to get it, but something like the U.S. Navy's VLF communication systems that can get up there, and it was how they interact. And So I don't remember the all the details of the article, but he was mentioned. That's why I'm reading the article going, oh, wait a minute, I know this guy.
Mhm.
Yep.
So anyway, that's about all ham radio wise that is interesting. So that I have for tonight. So $73, back to net.
Okay. Next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. Yeah, that article, Bill Engelkey emailed me, so I decided to post it on the group. And then, interestingly enough, the same article from on a different website was posted by someone on the VLFgroups.io. So that was actually pretty cool. What I would like to do for the general discussion, I would like to talk about the VLF power supply. I think that's very important and pertinent, and it needs to be discussed. I've been working on the GPS modules. I found out the power jack that Paul used was the standard DC power jack that I got, which has the same which has different manufacturers, didn't fit. The center pin lug is wider than the shield lugs, and the one that he used was a Chinese part, which had the center pin lug the same size. So these obviously didn't fit in the boards that I have. So I had to order those from China with a very hefty shipping cost. That's all I have. Back to the net.
Okay, well, I'll put that item on for after the roll call. Next on the list is Scott Newell in 5 TNL. Go ahead.
Hey, I spent the week finding and fixing bugs, testing Paul's little injector, just stuff like that. So back to net.
Very good. Next on the list is Rob Robinette, AI6 BN. Go ahead, Rob. Still might be. There you go.
I had my audio muted. Okay, well, I think the biggest issue I've been working on has been working on the South American deployment. We're staging the stuff in London today and uncovering a few bugs, incompatibilities that have to be addressed. I think the biggest issue, though, and timely one, is exploiting and deploying and testing the time accurate recording capabilities. That's Paul, who is on the road today. Paul Elliott is driving, so he's not with us, but Scott has been working with him on this time accurate recording, and we were going to deploy that at first at WWV, the receive site we have out there. So that's Dave Schwartz, who operates that site for us, is exploring what we can do to upgrade that site for a number of our purposes. It seems like it's very timely to do it in the next couple of weeks, because after that it gets to be winter and he travels and then it becomes winter and it becomes harder to put up things. So we're I suggest at the time both to upgrade the server, the V-Link, and to add the time injection signal equipment, but also to maybe upgrade the receive antenna, which is currently just a simple vertical, and there's a lot of noise. It's a very noisy antenna. So it seems possible that we could deploy a SAS there. and improve the sensitivity of the antenna and its immunity to local noise. So that's something that George Burkett has the SAS parts in stock. So we could, and I have I think Scott has the parts. Nathaniel sent me the Bogner arrived today. I have the server, so it seems like we could get all those parts to Colorado this week, by the end of this week, and I could even go next week for a few days and work with Dave to upgrade that site. I view that site. I hope others do, as kind of our reference receive site because it's so close to WWV that the perturbations and impairments introduced by ionospheric refraction are minimized. And so we can kind of get a baseline for what the kind of level of performance we can get from the rest of the DAISY sites. So that's what suggests to me that this is worth my time and our investment in equipment, if you all agree. So that's my biggest issue to discuss this evening. So I'll send that back to Net for.
Okay. Okay. So I believe I've called on everybody. Is anybody missed? That I missed? If not, we'll be open for general discussion, but we have two items listed, VLF power supply by Jonathan, and then the WWVE discussion by Rob Robinette. So it's open discussion, but those are the two items that we should address first.
Jonathan was first. He
Yep.
should get to go first.
Jonathan, go.
So there was Elmer did some testing on some filter networks. Elmer, can you talk about that?
Sure. Jonathan provided a document from the manufacturer who had a third party analyze emissions from a DC to DC converter. And to best explain that, the filter is on the input to the DC to DC converter. The load itself is, as shown in schematic, is just a resistor. So anyway, I applied those filters to the DC. Well, let's go back. Clint had suggested back in the day, and this is a while ago, that I put a capacitor across the input to output, which killed the common mode issue that I was seeing. And from that, the thought was that we were going around the isolation with that small capacitor. It was 47 nanofarads. Because this DC to DC would interfere with HF. Fast forward, this filter was for an emission. The filter at the DC to DC converter on the bench with the filter with let's just call it a load, which is a resistor, not touching anything. I could not observe anything in HF, normal HamSCI installation. The attachment of, and this is a split rail power supply, so plus minus. The minute I touch let's call it the ground, to ground itself, earth, then I would see the DC to DC switching again because I had removed the capacitor. I tried numbers of combinations of that input filtering. Then I applied input filtering and output filtering, but none of the filters, nor those that I've tried earlier, provided any reduction in seeing interference in HF from the DC to DC. The only way that I was able to null it, I'll give Clint the credit here, was to take, say, the ground input power through a 47 nanofarad to the ground output of that DC to DC, at which point the noise that I can observe becomes minimalist, almost invisible. I would almost have to put an antenna on top of the DC to DC to see it. That said, I've contacted yet another DC to DC converter company who published their schematic, but I asked them what frequency it was on. I haven't heard back from them yet. I don't know if they'll reply, but looking for a DC conversion that's isolated for the VLF project is the goal. I've tried coil to coil, and if I move the frequency, that seems to be a nice solution for getting power out to the antenna, but we still have the DC to DC converter for the split rail amplifier at the antenna. Did I cover it, Jonathan?
Yeah, and did you use the LC filter with the values recommended by that document?
Yes, and combinations thereof, because I had them sitting here, so I just tried everything. And again, the power supply itself, and I call this flying. So I have a power supply in the shack attached to the DC converter with the filter going to, let's say, a resistor in space, not touching anything. I see no radiated energy in HF bands on my system here. It's the moment I take the output side of that DC to DC, any point of it, and attach it to ground, because the antenna amplifier is grounded, and the design for it is that let's call it the ground, which is in between plus and minus, if you want to call that ground. Once that's touched to anything, even a alligator clip with a short wire, I get radiated energy. Filters in and out, no difference. Only the capacitor across made it go away, meaning from input to output.
Did you try, let's say, like adding, so the recommended LC filter did not make any difference?
In the circuit that we're trying to use it in, no, that's correct.
Okay. Did you try?
If I could float it, if the amplifier is just floating, no antenna attached, no ground, no issue. I could power it up, no issue, with that one DC to DC. The minute I touch something to that assembly, I'm getting common mode issues.
Did you I was thinking about say combinations of like multiple LC filters.
Yes, in and out.
Well, you got to remember what these power supplies are for. These are point of load supplies. And the only thing that they have to be quiet on is conducted emissions on their source side. So if you wanted a power supply like that to be quiet, you'd have to do one thing, which would kind of be awkward. And that would be to put a Faraday shield between the primary and secondary that is symmetrical, so you guarantee absolute symmetry on the magnetics. The only reason the capacitor works is, and the reason you have noise at all is because the transformer is not symmetrical. I mean, it has the same problem as the T11, which is, is somewhat symmetrical, and it gets less and less symmetrical as you go up in frequency. But making a Faraday shielded common mode transformer that covers many, many octaves efficiently is extremely difficult. But the thing is you don't need to worry about that as much here. But anyway, but I think if you did have, if you were to somehow design, if you were to have a extremely symmetrical transformer with
Well, no, the problem they were solving was just what you said.
Yes.
Source supply emissions. That's what it covers. The
Exactly.
load itself is demonstrated as a resistor floating in space, not attached. Hence, once I violate that, then well, hell in the handbasket.
Right.
I even built a small FET switching supply just for giggles. When I got it working, it looked just like the one I was trying to fix.
Right. Well, yeah, yeah. Yeah.
I mean, the only other way would be to do, like you said, what was that? The current source, because I was looking at the LT101, 1010, whatever, and do a split rail, single voltage, 12 volt, non-switched output to get a split rail going, which would redesign it, but use an op amp to do a split rail power supply to get the plus minus.
Right.
But we need at least 100 and some milliamps, upwards of 130 maybe, to be safe.
Right. Whatever you design won't be particularly efficient, but also it sounds like 100 some odd milliamps. You're probably not keen on putting a 100-watt solar panel out there just to run the.
Well, the solar panel concept was shot down because of the shot noise of the panels.
Yes.
I built one. I've got it. It's next door. The switching the coil to coil using these little phone-like charger systems.
Oh, the QG stuff.
Yeah, if I change the frequency of this, it creates a thermal problem on my device. I would have to tune it to be more efficient at the frequency I want to go to. I was trying to drop it in at around 100 kilohertz, below 2200 meters, but above VLF, let's call it. So that was one of the concepts to drive it. But we still have the DC to DC plus minus requirement out at the antenna amplifier itself, unless we were to split rail something.
Right. So I guess the the 47 nanofarad does badly violate the.
I don't know that. No.
We don't know that. So what you're saying is we don't know that.
We don't know what the violation is to what level. How to measure that? I can't do that at my shack. I am so violated here by noise in New York City. My ears hum without even plugging them in. So
right.
I can't even try that. Now at Nathaniel's place, maybe we could put a switch in and turn it on and off and hear it, but I don't have any scientific way of putting this on a bench.
So what you're saying is you may have solved the problem already, but you don't know it, or is that not true?
Yeah, that's it.
Oh, okay. Well, I mean, it's I guess an obvious thing to do. Although messing around is fun, it would be maybe the thing to do would be to try it and see if.
Yeah, but how do I arguing for Jonathan is how do I validate that the 47 or even less? I've tested 20 today to see if I could spot it, and you find some happy mediums. to give somewhere because there's always compromise. But how do I determine how much compromise there is in VLF? How would I set up a test? Is there some way I could bench it?
Yeah. So see so remember that screenshot that I sent you showing a power spectrum and the arrow pointed towards the harmonics that were at the lower end, up to about 8 kilohertz. See, because this is kind of what I was thinking. Is where we set up these DC to DC converters, and we add our filter networks. We set them up in a configuration that they would be connected. So one, the one, let's say the one that's in the shack board is powering the one that's in the preamp, and we wire up how it would normally be connected. And what we're looking for is the absolute minimum amount of audio signal up to in at around 10 kilohertz, let's say, that can make its way from one end to the other. And my thought was, so we set up a circuit on the bench, and then what we do is we get a function generator to generate some audio tones, and let's say we inject it through a capacitor on the power input of the DC to DC converter that's in the shack. Okay, and then we look at with our spectrum analyzer at different parts of the circuit, where is the signal? Is it present somewhere? Is it leaking through somewhere, somehow, through these filter networks or whatever?
Jonathan, you're saying injected at one end. That's not a current loop. You're just injecting a source and seeing if the circuit itself filters the single source at one end. What about the current loop from one end to the other? Because right now at Nathaniel's location, I believe, with whatever's going on in his house, which is yet a whole nother month's worth of conversation, that there's a loop between the station and that antenna location out there, because even the DXE, at one point I was seeing, let's just call it VLF noise, and everything else around it was turned off. So it wasn't so much that the source is a point screaming into the end of the cable. It's a loop all the way out and back again that includes Mother Earth. So the question is, how do we know that the isolation is compromised? It's not a filter. We're talking about current loop, which I think is different. Maybe I'm wrong.
Well, no. You're right. But like what I was talking about was you wanted to test or at least quantify the ability, the isolation ability, right? And what I described would be one way to do it, where we wouldn't only just put in some sort of audio signal at the power input. Then we would also put it on the loop, and then we would also put it on the one of the rails on the preamp end, and then we just measure these points, and what you're doing is you're evaluating the leakage, which should be at a minimum, but that's just for that circuit, right? And then what you describe also, that's the other issue where we have other ground loops in play. So if we want to try to isolate this, we want to do like a VLF only. So if we want to understand what other ground loops can be in play, we set up our VLF receiver, and we disconnect the feed line to the DXC antenna on both ends. We disconnect it. We don't even use it. Everything's disconnected. And then what we do is so you have the capacitors on the input and output on these DC to DC converters. And then we look at the power spectrum. Do we see higher frequency harmonics on the power spectrum, which will, reach up to 10 kilohertz? Do we see that? We kind of eliminate all paths and just the VLF, and so that we could effectively see that if these series capacitors from input to output really do break isolation, that could be one way to see whether they do or not, right? I remember when you had the series capacitors installed on both ends and you plugged it in, that it hum like crazy, and that made sense to me, because we were breaking AC isolation. We don't want to do that. But I don't think we fully tested it at Nathaniel's house. I don't believe that we actually tested that, because I think to kind of isolate these issues, we're going to have to test these things one at a time. So we, at least initially, so we understand what these paths that we might not be aware of, that might be dumping harmonics, where they actually come from, and then this way we know, without having multiple things running, because that could make things a lot more complicated. So at least for the VLF system, we disconnect we disconnect the feed line at both ends, just let it hang, and then we do our testing. And then we could actually test. We could see whether these series capacitors actually do violate isolation. My guess is they do, but we never really tested that. And then, so that's one thing we could test. We could also test that bench setup that I was talking about, injecting an audio signal at different parts of it, and seeing if it's present. We could try with series capacitors, without, and then we'll know, are we really violating isolation, at least in that circuit? And then we could go to the test at Nathaniel's. Or at least that's my thinking. If I was going to do it, that's how I would approach it. Because then we would know for sure. And now, Clint, now you mentioned that these DC to DC converters, they often don't try to eliminate the issue of emissions.
No, that's not what I said. What I said is there's no need for them to be quiet on their load side, because these DC to DC converters are typically what are often referred to as point of load converters. That means that there's somewhere on the circuit board that is designed for EMI compliance, and their output goes to something that is local to the board. So if they produce garbage or something, if you've designed the board right, you confine the current loops to the board itself. And so the grunge they're producing on their output doesn't get radiated. But so what they are designed more often to do, though, is that on their supply side, let me try on the thing that is inputting,
right,
that they constrain the conducted emissions on that side, because you have typically on a device that needs several POL converters, you have a bus that is shared with everything, and you do not want to grunge up that bus unnecessarily. And so there is no need to pay too much attention to the to how much they conduct in that way. I mean, they're already on a piece of equipment that is designed to avoid emission anyway. So using these things the way we're using them is probably not what the EMI compliance, the people with the EMI compliance hats that designed these ever had in mind. And I can imagine somebody with, cringing anytime one of these are being put into, being shoehorned into the sort of service that is being attempted here.
right.
Which means, I'm not saying it can't be done, which means that I wouldn't put any onus on the manufacturer whatsoever to come up with something that doesn't produce differential grunge. I mean, and that's what we're talking about, is we're talking about currents that this thing induces on the line through it. So when you talk about testing it, the most easiest and obvious way to test this would be to, I mean, if you wanted to build a test jig, you have a couple of batteries and a double pole relay at your antenna. So you flip switch A, the thing sits there, runs on the batteries, and you flip it to position B, then it runs on the DC to DC converter. And then you do an A-B comparison and see if there's a problem. I mean, you're talking about injecting stuff, signals into this and that and the other thing, but the real proof is in the pudding. You don't care if it radiates or not. What you want is to make sure that it doesn't radiate enough to be audible on your receiver, because you're never going to get it down to zero. And practically speaking, all you really need is to make it so that it's invisible in your installation. And having a and if you were to design the power supply system, you could run on batteries and have an A/B switch on it. That is something that you could build into every device out there, to just as a matter of course. If you had a commercial device, you have that A/B switch on it, and you have instructions saying something like, okay, switch it to the battery mode and switch it to the other mode. If you see more noise, you need to clean up your station because you have current loops. I mean, that's something that is a facility that would be useful for anyone installing something like this, no matter where it was coming from. So anyway,
Oh, yeah. No. There was some confusion. I should have specified. So what I was talking about wasn't necessarily the HF emissions that are coming from the DC to DC converter. I was talking about the AC isolation.
right, and so was I. Yeah, I mean, if the gold standard would be to have a device like this that is totally galvanically isolated, and that would mean either having a portable receiver out there for testing, optical, or if you can come up with an appropriate balanced and Faraday shielded isolation transformer to convey the audio. And such things exist because, those things have existed for 60, 70 years at least. I mean, then you can totally isolate the audio. Don't forget that for much of broadcast history, audio for broadcast radio was sent via ordinary copper paired telephone lines. Miles and miles. They were the copper equivalent of dark fiber in that they didn't have battery voltage or anything on them. They were just, you rented several pairs of copper wires from the
We
phone
did video
company.
that way too.
Right. You could, yeah. There's some sort of sage line. I forget what it is, but for since the 20s, you could get 20 hertz to 15 kilohertz audio
Right.
from audio lines from the phone company, and there are transformers that do this with absolutely fantastic isolation, and these are Western Electric devices. The ones that I know of are usually oval transformers. I don't know what they're called. There's a name for them, but they were usually oval. They were like, in 1950s, $60, they were hundreds of dollars a piece, but they were absolutely fantastic in conveying stuff down the line. Now you did have to apply some EQ to them to make sure it was flat on the other end, so you would pass proof on your transmitters, but at least you didn't get common mode noise and coupling of the sort you're trying to avoid here.
Right.
And the way they did that was they had way oversized transformers and Faraday shields and interleaved windings, and I don't know what else. There's all these magical tricks that the audio folks can do to, and also the other thing too is they were kind of lossy, which isn't an issue here because you can afford to burn up a couple of dB amplifying it. But I mean, in some ways, this is a solved problem in conveying the audio, except for the voltage part. Now, conveying the voltage part down the line, I think, is the problem we're trying to solve. And I guess what we don't know is that if the things that Melmer have done are actually sufficient or not.
So to your point, though, I think you nailed it. If we were to put, I'm just going to throw this out, 2 9-volt batteries down there and a simple switch.
Yes.
We can flip between this and that, and instantly we will know.
Right. In fact, I was just looking. Scott is pointing out World Radio had a column on these Western Electric transform a few months back. They're highly sought after these days. Like hell they are. Yep. I saw some on eBay a while back, and I wasn't going to pay that much for these suckers. No. WE111C is what he's saying. I don't know what they were, but I think those are the oval ones, but I'll have to look. But yeah, But yeah, so but anyway, but yeah, I think you're right. I mean, we need to, you know, there's, I'm reminded at this point that the perfect is the enemy of the good.
Well, at this point, I'm going to shoot Jonathan here for a second so he can shoot back at me. But when we did his antenna system unmodified, my antenna system modified, and we went back and forth, I believe I heard I can't hear a difference. So, not saying that solved every problem, but at what point, when we do these measurements, let's assume we find something out, whatever that might be, do we say that's good enough? Or is there always going to be the question of, no, we can't do that because it breaks something? To your point now of there's give and take because HF is involved here too. I got to make both of them work together.
Right. So when my system was still running at Nathaniel's, we didn't really do any sort of qualitative measurements before things were installed.
That's my point. How do you make a repeatable measurement as opposed to waiting for an event? How do we make that with your antenna system or any other system at VLF?
Well, so what we would be interested in is looking at the harmonics, looking at the power line harmonics on a spectrum display like VT spec or something like that, or the website that I got that plot from. When those harmonics weren't there, that's when the system is performing optimally. When they're there, then they're going to drown out natural radio signals. So that's what we would want to look at. We'd want to look at if those harmonics are present. And me, since I've done this for many years, I could kind of tell by ear, but it's not always easy in every situation to discern small differences. So so in that case, we would just want to look at we would want to look at that spectrum display, and that's how we would know whether it's working like it should if those harmonics are not there. And the harmonics
go back to what Clint said though. What if we just put I'll just, because it's easy, maybe we do something else, but 2 9-volt batteries supplying instead of the DC to DC. Now you have 2 batteries at the base of the antenna, absolutely floating in space, and that's reference. And then we go back to the source, which is the DC to DC modified, and the difference between that is what we're measuring.
Right. I mean, the gold standard for a given location would be to have this totally isolated receive setup that isn't tied back to your shack. The only thing you can really fix once you plop down an antenna in a location is, for all practical purposes, is to make sure you do not make it worse by whatever means you convey that signal back to your shack. And what we're talking about is the exact same sort of thing you would do in a site survey. I mean, if I'm putting an antenna out there and I have the option to do so, I will walk around with the portable receive setup and find the location. It might be a corner of a yard, or it might be something, you know, where things null out for who knows what reason, where things are quietest. And then once I determine that the standalone receiver thingy, whatever it is, excuse me, then when you connect it back to the shack, you don't make it worse. And having the isolated, with the batteries and the transformer and stuff like that, back to the shack, the only way you can possibly diagnose it is to be able to quickly quantify the difference between standalone and connected to the shack, and then that will inform your decision on what you need to do to remedy the issues as you find them. So that's what I'm totally with Elmer on this. And nowadays, I mean, and one of the easiest ways to do it, like I've done this in the past, is, I have some very small, low-powered FM broadcast transmitters, just tens of milliwatts perhaps. And the advantage of those is you can hang them off something and cover from a few tens of hertz up to, maybe 10, 12 kilohertz. And that thing is totally standalone, and you can move it around and walk away from it and still hear what's coming across it. And, to your point, Jonathan, you can, to a large extent, you can tell by how raucous the buzz you're hearing on your headphones, whether or not what you're doing is the right thing. And that would be a quick and dirty way to convey signal back to the shack or whatever with a just small transmitter, if you didn't have a coil or something and it didn't want to run it. But just walking around with something with headphones on it, battery powered, is probably reasonable place to go. But also these days, since you can get like to get the Spectroid app for your cell phone, which is a decent spectrum analyzer, audio spectrum analyzer, and just shove audio into it. So you don't necessarily need to have your ears anymore. You can, on your phone with software that is free, you can make some approximate quantitative measurements, like what's the SNR between NAA and I mean, how big is the SNR at NAA's frequency, for example? I mean, when you walk around, is the noise floor going up and down compared to the actual on-the-air signals? And that's the thing you really, really want to know.
They have dessert.
Anyway, over to you. So I don't mean to dominate all this, but go ahead, Elmer.
No. I'm going with you. The only thing I want to bring caution to, though, is this test that we're talking about doing includes this 200. I'm going to say it's 275 feet run that goes out to the VLF antenna system, and I now having two DXE antennas out there and have moved the SAS antenna around. There was, depending on time of day, what's going on there apparently, because I keep watching it, noise differences closer to the house and then further away. To my surprise, Saturday when I was there, the noise out at the antenna field was quite a bit different at the VLF frequencies than if I looked at it closer to the house. So I still believe there's currents, some kind of strange current going on in that area of Nathaniel's house. And I, until we find it, it's a mystery. But it could be that somebody's farm nearby is still leaking into the ground horrifically. That kind of thing. So I don't want to have a test that is possibly dependent on 300 feet of compromise in this test, because we may never achieve nirvana, if that makes sense.
Well, what we did, I don't know, what VLF noise were you talking about? Were you talking about those?
Well, when I looked at the, let's just say 24 kilohertz on the DXE, after we went over to separate DC supply, so I was going around the bias T's and everything else. Again, it's, there's attenuation there, but at the house location, let's call it, the one nearest, there was numerous, and I could show it because I have it here at my house too, and I'm trying to figure out what causes it. Numerous, it looks like a comb turned upside down. You get these little spikes all the way across, Yet when I looked at the DXE up far away, up at the top of the hill, 270 feet away, I didn't see those up there. So it's like back and forth. Where is this? Oh, actually, I take that back. The noise was up at the top of the hill, but it wasn't down at the house. And the only thing I could come up with is the ground rod up there is in a different part of the ground than down at the house, because house was free of the around 24 kilohertz. Again, you get this, it looks like a comb. You just turn a, multi-comb, and every couple of hertz there was a spike. But going down to the house, I thought it would have got worse, but it got better. And then I ran out of time. But there is still something going on with, I call the top of the hill. And we disconnected the magnetometer, the DXE, anything that was going up there individually. And we tried different power supplies because I have batteries there now. And we tried transformer, we tried battery. And all of those things made no difference to what I was receiving on the DXE at the top of the hill. VLF turned off, magnetometer turned off, everything was being shut on and off. Nothing changed it. Now I looked at it again today. I didn't see that same introduction of noise. We've had rain. I know my location here went from being, I told you before, crazy here. Well, I got VLF turned up in the back of me, and I'm listening to the Spherics right now. 2 days ago, I couldn't have done that. This place was humming like crazy. Whatever happens with rain up here on the sand makes conductivity completely different. I'm still making measurements, so I'm trying to figure out what causes all this. But it's insane how much it changes in a few days. So
Correct.
anyway, when I'm making these measurements, or we make these measurements, I want to make sure that we know that the environment's changing all the time, and we can't avoid the environment because we're part of it. That's all.
Right. Yeah. So I also noticed that as well. Whenever it rained, the hum levels would increase. I don't know why, but that's what would happen.
You see, on mine, it goes down.
When it rains, when it gets wet, the hum levels increase.
Well, in his backyard's marsh.
Yeah.
Mostly. So
Yeah.
again,
I couldn't really pinpoint exactly why, other than the design of the antenna and the use of the aluminum mast versus a wooden mast. But I don't know for sure. I didn't really test it, but I did notice that. But like, I wouldn't worry too much around 24 kilohertz. The main thing that we want to achieve is the natural radio part of the band, which is below 10 kilohertz, or well, below 8 kilohertz is really what we want to get the cleanest. Yeah, the things have changed at Nathaniel's house lately. Well, since we've started testing, but we kind of need to like maybe do a better job in like isolating our tests and making sure that we're trying to test one thing and not have it, other factors influence that. Yeah, as far as what you saw at around 24 kilohertz, I don't know what that is.
I see it here too. So a lot of things I saw there, I see here as well. So anyway, not to hog the whole evening.
Yeah, Yeah, no,
I think the next step would be to do what Clint recommended, is possibly install a simple switch so we can go completely isolated up there, and then go to the DC to DC with whatever we want to try. And what we pick up on some analyzer, be it phone or other, use that as the reference to see if we've improved or have no change or whatever that we might witness. I doubt I can do any of that work here. My station, and I've tried antennas and grounds and moved grounds, and all I can go is from bad to worse here. My neighborhood is just, there are too many swimming pools, people with skill saws, you name it. Although tonight, again, I'm listening, and I'm listening to raw, and my raw has no hum in it. Now I'm using the SAS as the source, but I've used that for many, many months. And after cleaning up the shack in the last 24 hours with linear power supplies, I got rid of a huge amount of introduction of noise here. So I'm getting closer, but using a ground rod in my backyard is not going to be achievable. I need some kind of 2-pole antenna or some other antenna that doesn't touch earth.
Many years ago, where I'm living now, I installed some coax runs to the back of my garage, where I have my garden, and then there's a ravine. So it's an area that's kind of away from power lines, and what I wanted to do was I wanted to look at the hum levels and see if it's something that could be used as a VLF testing site. So I spent the weekend getting all my cable runs back to the way they were, and putting fresh new connectors on. They were used for C-band and KU-band satellite antennas many years ago, but since I already have the cable run, I was just going to use each coax as a pair. One is going to deliver power, one is going to deliver signal, and it'll be a test bed. So I have to see how well that actually works. But I could actually do like a similar test. But anyway, yeah, I think that powering with batteries and then switching over to the DC to DC converter with whatever configuration would be good. Now, Clint, the question that I had for you was, could we use LC networks on the output to help this issue of?
Well, as I said, the problem is not the output so much that the output is producing garbage. It's the fact that you are getting current flow between the input and output. I mean, you have a galvanically isolated DC to DC converter, but that does not mean it's isolated at AC. Once you, I mean, you have a asymmetrical coupling between the primary and secondary, which means by definition you're going to have RF currents induced across that, and that is the problem. So the quick answer is absolutely nothing filtering you can do on the output will solve that problem. There's absolutely nothing you can do to solve the problem of differential currents flowing through the device.
Right.
That is the absolute wrong thing to do. That's why I suggested, to Elmer, that you tack a capacitor across it. Fortunately, those currents are very small. And they're very easy to get rid of. But I think what I've learned tonight is that nobody has actually bothered checking to see if the problem has actually been solved. I mean, I mean,
Well, no, it's solved. It's
oops,
on the HF side. The problem is we haven't tested to see if we violated the LF.
well, that's what I meant. Okay, yeah, the problem of preserving galvanic and isolation at AC, or at least low AC,
Yeah.
that has not been determined. I mean, we may be just running in circles because the problem may have already been fixed, but we don't know. But the thing is uh, uh, even at really low audio frequencies or moderate audio frequency. Well, for example, let's see here. Even let's see here. I'm just looking to figure out what the reactance at 10 kilohertz of 47 nanofarads. Let's see here. That'd be 47,000 picofarads. So that is 300 ohms at 10 kilohertz. Even if the 47 nanofarads, with the 300 ohms of choking impedance that you put in there wasn't high enough, you could still throw, a couple hundred millihenries of inductance on the DC line to bring that back up again. Just as long as you don't inadvertently form a series resonant circuit or some resonant circuit that would make it terrible at one frequency. But
So what happens if we drop it down to 20 nano? Because that's what I'm testing now.
well, I mean, then the impedance will be 600 or around 600 ohms. I mean,
Okay.
Well, yeah. I mean, it's what is it? 1/2 pi FC. That's that frequency. You learn that in you learn that. Yeah. You know that one. Yeah. I mean, that's um, so it is absolutely proportional, and you could probably, if 300 ohms, I mean, what you're doing at 10 kilohertz, you're essentially tacking 300 ohms or 300 ohm resistor, 338 ohm resistor between your shack and your house. If
Yeah.
that
Right.
may or may not induce enough current to be a problem, depending on your ground impedance and what the magnitude of those signals are. Even if it was, let's see here, if you could
Well,
probably
remember, it's double isolated. It's isolated in the shack, and then it's isolated yet again out at the antenna.
okay, then it's
Yes.
maybe 600 ohms. But then again, let's see, if you got some let's see here, like 10 millihenry chokes and added those to the mix, those have, guess what? Those have 600 ohms impedance at 10 kilohertz. So even if you could, these frequencies are enough that you could, if you needed about a k ohm of isolation, you could do that with the 47 nanofarad capacitor across it and put some 22, 33, 47 millihenry chokes in your DC line as well. I mean, the big problem with those is that they saturate easily.
Right.
But the thing is if it is common mode, then you can make a bifilar choke. You can make a bifilar choke using some of the more exotic mixes, like some of the W mixes, for example, of that have insane permeabilities where you would have negligible current and you wouldn't be saturating your material. I mean, this is a solvable problem, I believe. I mean, you're not going to get it to hundreds of K impedance of isolation, but I think you should easily be able to get it into the several K ohm isolation as well. And don't forget too that cable that you have buried in the ground is going to have like 20, 30 puff per foot coupling into the dirt.
Yeah.
anyway. And
Yep. Yep.
you know, if you have 100 feet, you know, if you have 100 feet, that's 300 puff. That's going to induce something, but you know, stuff like that. But anyway, I don't want to beat it. As I said, I don't want to beat a dead horse. I think the time is ripe for testing and determining if how much is enough. Let's see here. Scott asked, are converters normally isolated? The ones I've used are not isolated. You can get them both ways. The isolated ones are a bit more aren't as common, but they're I mean, they're easily obtainable.
Yeah, they just charge a little bit more for them.
Yeah, I mean, they're a bit more complicated. They're usually like SEPIC, or I imagine they're probably SEPIC. I don't know what the topology is of the converter, or Chuck, or that CUK or whatever. Those are, I think, the fancy topologies they're using nowadays. Somebody would correct me on this for the transformer isolated ones. Also, they're a bit harder to regulate, because unless you pass use an opto isolator or something, you kind of have to rely on the coupling factor being good to kind of assume that the output voltage would be constant based on what you're putting into it. In this case, that is totally irrelevant, because you don't care what the voltage coming out is. Is it 8 volts? Is it 12 volts? I don't care, as long as it's clean and reasonably stable. You know, with modern op amp, you don't give a rat what it is. You know, as long as you have enough margins for your signal dynamics. So you don't even care if it has a little bit of ripple on it. You know, because modern op amps will have what, 60, 80, 100 dB of CMRR in a properly designed amplifier anyway. So anyway, I mean, this sounds like an interesting problem, but I have this nagging feeling you may have solved the problem already, or 99% there. So,
well, Clint, the thing is, like hundreds of ohms of reactance, like that's the issue, that we from my experiences with this, at least, that we want to get this we want to get that as high as possible, but see, that's the problem, because once you start adding capacitors, which will give you, let's say, hundreds of k ohms of reactance at those frequencies, then I would imagine that they're going to be that they are not going to be effective at the HF emissions. So,
well, I mean, the HF problem is a very easy one. The other thing too, Elmer, I mean, you could add one thing you could probably do is you could probably add a couple bifiller or even a quad filler choke to your DC to DC converter, and raise the HF input impedance a couple orders of magnitude to where a nanofarad would probably do the job. I mean, so I said it before here. The perfect is the enemy of the good, and what you need to do is you're never going to get it perfect.
right.
Getting it indistinguishable from perfect is good enough, certainly. So I think what needs to be done at this point is try the things that you have right now, quantify it. Then at least you'll know to what order of magnitude you need to go. Like for example, to a little bit of a degree, I'll take back what I said about the LC filter not helping on the DC to DC converter. I mean, if you add a crap ton of more inductance to the input or output, doesn't really matter so much. But you might as well make it both if you, with the right magnetics, you can wind the right magnetics to kill two birds with one stone. You could increase the reactance of the input output filtering so that you could get probably an order of magnitude less capacitance bridging the input and output to still have the same effect, I think. I mean, Elmer, you're just tacking the 47 nanofarad across the power supply as it is, right?
Yes, short leads, but yeah, it's on the back side of the board.
Right.
Actually,
So
today I put a different one on, but it's as tight as I can get it.
So if you were to add a couple hundred microhenries of inductance on the input and output, let's say 100 microhenries let's see, let me run the calculator.
I've got a bag of those sitting here, so that's easy enough done.
5 let's see, so 100. So if you 5 megahertz, 100 microhenries is 3K. So I mean, and you have, I don't know what is on those converters. Typically it's on the order of tens of microhenries. So if you added a few hundred microhenries of additional inductance on these things, you could easily raise your X of L by a factor of 10.
Right. But again, I'll go back to the fact that as soon as I touch, well, because I've never seen it reduced other than this capacitor. As soon as I touch, let's call it the center, ground, between the plus minus lines, that's when I see it eject itself into HF all over the bands.
Right.
Those inductors on the plus and minus.
Well, no. So let's see here. Let me find a piece of paper here, and I'll scribble out what I'm talking about. Scribble what I'm talking about. It's
Am I doing all three? Looks like I'm going to be winding something.
Well, I mean, a lot of people are scared of winding toroids. But
well, if I make 30 of these times X, yeah.
Well, I mean, these are things you can buy, for heaven's sake. I mean, you could buy some Corcom units, and do the same sort of thing. Okay, so I don't know how well this will show up. Oh, I'm glaring. There it is.
Oh, there you go.
So
this is the regular line filter that I get put on the AC lines.
Right. So see this capacitor I'm pointing to?
Yeah.
That is the capacitor that you've been sticking right across the power supply. But add these extra inductors on the input and output, and you can raise the X sub L by order of magnitude. So this capacitor can be a tenth or a hundredth of what it is now and still do the job. Because the 47 nanofarad you said it had short leads. That's a dead giveaway that there's a fair amount of currents there. If the lead length makes a difference, that means there's
no, I didn't say that. I just said I made it as short as possible.
Oh, okay. But you can kind of, I'm kind of leading you into it. If the lead length did make a difference, the current was fairly high there. But if you put a couple hundred microhenries, which is just a dozen or so turns on a small T50 or FT 110-43 or 77 or whatever you got, a dozen or two turns on there. Suddenly you have 300 microhenries, and that's going to probably do a great job. The other thing too, actually, what I would do is I would actually have this other capacitor as well. I mean, oops. So here's the capacitor already had. These things. This already did a pretty good job. And no, actually, you wouldn't want this one. Never mind. Ignore that, because
you're now not using the inductance to help you.
Right. I keep forgetting to put my VLF hat on. We can't have this inductor. Anything in parallel with this to maximize VLF, the capacitance needs to be as small as possible. But you can do that by making this and this as big as possible. And don't be afraid to make these capacitors right here pretty big, because you want to force everything to common mode as much as possible. But those Corecom modules that get a 1 amp, get a 1 or 3 amp Corecom things. Those typically
I need plus minus. I need a plus minus power supply, so I need a 3-legged device, not a 2.
I suppose. Yeah, I mean, make a trifler then.
Okay.
You can't see that. I mean, yeah. Just make sure you bind everything, and also I would twist the inductors so that they have their coupling factors as high as possible. So, but anyway, I think this is a very solvable problem. I've solved worse. I've done this. I've done this on an 8 kilowatt inverter before, so and made it so that you actually had to put your radio right up to the stupid thing to be able.
Well, when I bought those big ass toroids and I put those on the my system, 12 megahertz was wasted here. Now nothing.
Yep. It's the fact that anything powered turns into a dipole. That is the problem. I mean, that you have that DC converter. The wires on it are just 2 legs of a dipole. You just want to short out the feed point of that dipole with these capacitors and make the impedance on the signal generator as high as possible before you get those shorting out capacitors. So yeah, I think
Right.
yeah, I think Elmer, in just like in 10-20 minutes, you could change that 47 nanofarad capacitor down to 1 nanofarad and get the same effect.
All right, a pot of coffee and a test. Got it.
Right. I mean, feel the wrinkles forming on the surface of your brain.
Yeah, right, yeah.
Or either that or you
Rob,
have too much coffee.
you're up next. We got to give Robinette a chance.
Yeah, go ahead, Rob.
Okay, guys, you hear me?
Yes.
Okay, so we're going to talk about let's see, let me get back here. I've been doing other things. Nathaniel, you're still with us. Okay, because you're, I mean, I think
I'm
this
still
is
here. Yes.
okay. I think that this is a subject for you, for you to decide what you want, as the organization to do. What do we want to do with the WWV receive site? Right now, the simplest thing to do is just upgrade it with the B-Link, and it will, it'll capture, and run more reliably and easily. It's marginal right now. The
Okay.
host computer is one that I donated to it. It's an old i5, so it's not quite keeping up with it. So that'd be the simplest thing to do. And and add the injector.
Okay.
That Scott, if you're still with us, I think if he were to send it to me, then I could forward it on to Dave, and have him install it. I wouldn't need to go. Now, if we want to go beyond that and improve the antenna system, then then we're talking about changing the receive site, and I think that Dave putting an SAS there.
Okay.
Because
What type of
would be-
antenna is there right now?
There's a kind of, I think it seems something like a random wave vertical. It's not an active. I don't believe it's an active vertical.
Okay.
The spectrum looks reasonable. It's worked reasonably well. It's not as sensitive as one might hope, but it's not bad.
Okay.
So the question is, how much value is there? And let's see, 4, 5, 8, 8, 1. I think this is. Oops, I was going to show you. Yeah, this is. Here we are. This is. I'll share this with you. Let's see. Let me zoom all the way out. So there must be a low pass filter in front of it. But I mean, you can see that lumpiness and so on. There's probably, I don't, you can see there's some kind of a null
Yeah.
okay, so that suggests that the antenna is resonant, negatively resonant. And what is that? It's 16, 17, 18 megahertz. So I think it might be, well, I don't know what that suggests. It would be half wave for half this, right? For 9 megahertz half wave. So it's good 10 or 20 dB worse than in terms of background noise level ingress.
Okay.
I mean, these, so we could improve that if we go down and look at, I don't know, there's a bunch of, if we go down there and zoom in, this is, that's not a particularly, you can see that would guess that's VB there at 60 kilohertz, but you're not receiving anything else. And then you can see the VB at 2.5, or the V at 2.5 up there.
Okay.
So this is, I mean, it has great signal noise ratio for the WWV signals. It's not very, it's poor for everything else, because there's all kinds of RFI that seems to be coming into it. You can see something just happened. I don't know, and this thing turned out again. So it looks like there may be something cycling in the. So I think that the question is, I think Scott, you've taken a look at it and you thought the signal noise ratios are great as is for looking at the WWV signals.
Yeah, I just brought up control and saw SNRs of over 30 to 40 dB on all of the WWV signals and said, holy cow. Of course, it's really, really close. So
it should be. Actually,
yes.
If we get better SNRs up at Glenn's remote site on the hillside.
I have never
Actually,
logged into that one, so I don't have a point of
I forget,
comparison.
I forget its rack number. Anyway, we could look at it. It's
But I would
but
like to mention that last email from Dave said, September 20th, he's leaving town. So
yeah,
there's not a lot of time to get everything together here.
yeah. Well, I mean, you can ship the injector to me. I have the Bogner and the computer. And so I'd have all the equipment here. And I think I ought to assemble it first, and rather than asking Dave to do it out there for the first time. So, I can get things to Colorado in a couple days. So we could have it if you were to ship it to me tomorrow.
That was my plan. Do you need it to go
Okay.
faster than ordinary
Yeah.
postal, though?
Yeah. Well, might want to do a priority mail second day,
Okay.
So that would get it to me on Thursday. I could assemble it and test it and ship it out on Friday, and hopefully he'd have it on Monday or Tuesday to take it out. So that would, that would give us the time reference, the new time accurate capability.
What exactly are you planning? Sorry, Are you planning on going out there yourself, or are you just planning on shipping things to?
Well, if we did anything more than that, I think I probably should go. If we're going to
Okay.
fiddle with the antenna, I think I should go. And I could go for, I could go next week. And do it, on site. And I've been doing a lot of remote support. Was working with Jerry in London on we uncovered some problems and fixed
Yeah.
them for him. So I can do that. And or I can go. I can do it remotely. I can go. If it's going to involve a change in antenna, then I think that's not, even Elmer has struggled, and I would need all of the support, remote support I could get from him too. But George has the parts. So,
Okay.
So he says for $235, he has all the parts that go into an SAS.
Okay.
And he has them in stock. So not as a TAPR product, but as something he purchased.
Right.
So, we would propose putting up a medium Z. I mean, this is, the signal levels are too intense for high Z, I think.
Okay.
I don't know. I mean, Elmer, what's your thoughts on that? What do we, we're looking at with this
The only
system?
thing that I see different between medium Z and high Z is the low frequency stuff, because
Yeah,
let's just call it 80 meters and down, you start to see a little bit of roll. But for the most part, I can't tell the difference between the medium and high Z at my location. Again, there's two different locations. One's on one side of the house, one's on the other. But for the most part, they're all but identical, to the point the medium Z doesn't overload.
yeah. Well, I don't think, I mean, you look here at what's the strongest signal here seems to be the 10 megahertz. And you can see it's at minus 37 right now. RF gain's at 15.4. So this is I think the AAA is operating at a very good operating point here. At this.
I mean, you can always put the SAS in high Z and then put in 5 meters instead of 6 meters, that kind of thing.
Yeah. Yeah, you can always shorten it, right? So
right. And that's what my first test was.
Yeah. Well, I mean, what's your feelings about the importance of, I mean, if we want to be a reference site and include one of our reference antennas rather than some arbitrary reference, this arbitrary antenna, putting up an SAS, I don't think, I'm a little worried about putting in a DXE because there's a lot of, this is a farm and there's pumps and grow lights and things around it. So there's probably lots of ground currents in the DXE. I don't think we couldn't get the antenna, as far as my inference is we couldn't get the antenna located away from those. So the SAS would be a better solution in that environment. It would do a better job of canceling out in ground loop induced noise. Now, if we go with high Z, then we potentially we can go down to to as low frequencies as we can. It's a so Elmer's been listening at 10 kilohertz, I think, with it. So it's a
Yeah.
So
Is this do we need to make this decision right now, or can we?
I think we can always go back later and put an antenna in later. There's no reason to do that. But it's winter is coming on, so if we're going to make some changes, it's either now or probably next spring.
Okay.
Antenna changes.
Okay.
So I mean, as I talk through it, I'm not sure that it's worth the trying to do both of these things at the same time. The antenna's usable. And the purpose here is to listen to WWV, not to be the best DX site possible.
Yeah.
Um,
I'm leaning towards waiting since we have a usable antenna if we just upgrade the other parts for now. But
yeah.
I haven't had much. I got the email this afternoon. I barely had time to think about it, and I've got like 3 million things that I've been trying to process.
Well, I'm talking through it, and I suggest it as an option. This is, we have, as I say, a window to do it now, or we can do it later.
Okay.
And maybe we should just focus on one new feature at a time. It's
Yeah. Yeah.
get the
Yeah.
get the timing thing.
I think that's a really good idea.
Okay. Well, then we'll follow along the path we're going with. Just Scott, mail me this. I'll test it. I'll mail it to Dave. He should have it by Monday or Tuesday of next week. And that gives him a couple of days before he's taking off at the end of next week.
Okay.
So
Okay, the only other concern I've got is this actually belongs to Paul Elliott. Is he giving the okay for me to give it to you and you to give it to WWV Zero? Because it's not
I'm
really
sorry.
mine to give away.
Well, say that again. I'm sorry.
I've got Paul's injector here,
Yeah.
and I don't have the okay from him to give it to you to give it to Colorado Springs. So, it's really his to call.
Oh, well, he's up for, he's fine with it. I know he's fine
Okay.
with having,
Okay.
okay, so they don't, no, I've talked with Paul about this. I just as soon not have him build another one of this
Me
version
too.
1.
Exactly. Yes. It's a lot quicker for me to ship you this one.
Yeah, I would rather him work on version 2 than invest in building another version 1.
100% agree.
Okay, good. Well, I mean, he's, it was all we could do, I think, last week was to persuade him to do to do version 2. Yeah, you guys understand that the version 2 will include a GPS in it, and with a PPS, and the oscillator, so that it's no Bogner needed for this. It will just require GPS RF, and
Well, that's a good point. Do you have a Bodnar available for WWV station?
I have one here. So I have
Okay, great.
Nathaniel. So Nathaniel sent me one which arrived today. So I have one of the mini dual output Wagners. I think that's what you have too, right? And so that my thought was that was to be associated. There's already a GPS DO out there. So there's a Wagner driving the 888. So that 888 is already so, but this would be a second Wagner dedicated only to the injector. And at some point, when we get a version 2, we'd swap it out and we'd free up this Wagner, and I'll send it back to you, Nathaniel, and send it someplace else.
What's your GPS antenna plan? Did you have two Wagners?
It's in a greenhouse, so you can just put another puck up, I'm sure.
Got it. Sounds good.
I'll send him the puck that came with the Nathaniel's Wagner.
How are you powering the Bodnar for the timing reference?
The Wagner will be powered from the USB port of the 888 of the B-Link. So it'll be everything. I power everything off of the B-Link.
Okay,
The
got it.
888, this Wagner, the second Wagner, the whatever is required to power the injector, the signal reference signal generator, all of that stuff would get us there. Get power off of the USB ports of the B-Link.
Do you happen to know what firmware version is in that Bodnar?
I'm sorry, do I happen to know what?
Which firmware version it's running?
Oh, the Wagner? I don't know. I haven't even powered it up.
Okay.
Because
The
I
Linux,
can do that. I can do that if you want. All I saw is on the outside it shows that output one can be a PPS and output two is whatever you set it to. So
right?
that
I'm using the Linux program that the I guess it's the Hydra SDR guy has a repo for. And that was one of the
yeah.
PRs I sent in this week, finding a bug and fixing that. But that program will not tell you the firmware version, and I could not find a way to enable the pulse per second over the serial port. Just thinking ahead a little bit, if I can find a way to turn that on, it might be possible to use that pulse per second over the serial port as an NTP timing reference, which would be nice to have as well.
Oh, I see. Yeah.
That's where I'm
Well,
going with that.
yeah.
And
Well,
and that is what you should be doing anyway.
Well, now
well,
remember it's USB, so it's not going to be as good,
Right, right.
but I'm hoping it's better than nothing. And I'd like to test that on mine, but I haven't got it working yet.
but that's the thing is that we're not dependent upon NTP here. We're
Correct.
right. I
This
mean,
is a
we're
nice to have, not a got to have.
yeah. I mean, I can stick a little USB, U-Blux puck on attach it, and we could have that as to set NTP. We're awfully
That
close.
wouldn't,
Yeah,
that wouldn't be any different than the Bodnar.
yeah. I don't think so. So
There would be no
yeah,
advantage.
good. Well, okay. Well then, do we have we agreed on a plan here? You're going to ship priority mail tomorrow to me. I
Yep.
hope I'll take this Wagner and stage it all here on Thursday, hopefully, and ship it on Friday to Dave, and plan on mentoring him to go set it up um, next week, Tuesday, Wednesday, and then we can do all software and so on. You can you communicate with this new Bogner, using the Linux program, or is it only possible
Yes.
from you can?
You can
just
do
can't.
everything. You can do everything we need to do with the Linux program.
Okay. Is that
And
the LB GPSDO package or what?
yes,
What there's okay. Yeah, that's
it's a
because
small C program, so there's not a tremendous Python dependency there as well.
yes, that one was unusable. The Python.
Yeah, I understand. No, there won't be a problem with this one.
Good. Okay. Well, so that's a plan, and that sounds. Uh, that was my item. One aside, just for I don't know if anyone here cares, but uh, I saw I got an email from Roland HB9VQQ, and he showing a diagram where he has a B-Link, like the one we're sending, same CPU we're sending to WWV, has a USB 4 hub, he said. I don't know, it needs to be that, with two 888s attached to it, running reliably. So you can use the USB-C port of the Bogner to drive at least two 888s. So Clint, this might be of interest to you because I'm sure you could drive a third one. So you could have three 888s, one on a USB-A port and at least two on the C port. And that'd be three 888s on a B-Link.
What would you? I'm curious. What did you envision a USB-A port with an 888 being useful for?
Oh no, the USB 3, I'm talking about the jack on the plug.
Oh, okay,
Okay.
okay.
So you could just as right now I've been always plugging in the 888s using a USB-A plug going into the
Okay.
blue jack on the front.
And to your knowledge, you cannot have more than one 888 running full bore on any hub, any single hub, though, right?
No, you can. That's my point. Is
Oh, okay.
Roland has it working that way.
What USB ports are available on the B-Link as as
Yeah.
uh
There's there are,
for the
let's
DAISY
see,
grant?
I'd have to go. There's I think 5 bus controllers. Let me see if I can log on to the 8745 in
Because
my lab.
I think I might have been told the wrong one to order, and I'm not sure the one I have is representative.
What's the CPU on yours?
I don't know. I can't get at it real quick.
Okay.
Sorry.
Well,
It's
this is,
we're doing the 5825, right?
yeah, we're using the 5825. Yeah.
Yeah, I'm
Look
holding one.
Yeah.
Look at this.
And it's 8 cores, 16 hyper-threaded CPUs. There there's
Uh-huh.
2 those, and the front of yours turned around, show us the front. You
Okay.
need to talk so I can see. Talk, Nathaniel, so you
Hello?
get.
Test 1, 2.
Oh yeah. Okay, so you see there's a USB-C and two A jacks, A ports that are blue. So you have a total of 4 blue colored ports plus a USB-C on that.
Okay, and 2 on the back?
Yeah.
Yeah. Okay, so well that's useful to know, because just for the magnetometer, I haven't I haven't I had a little trouble when I tried plugging what I've got into what appears to be a charging port on a USB hub, and it gave me weird results. But then it started behaving correctly when I moved it to any USB 3 or USB 2 port that I have tried so far. It only needs, well,
Yeah.
it
Well,
doesn't
this
need a
is,
lot of current. It's really a USB 2 thing.
yeah. Well, there's, it appears that the USB organization, I'm trying to cancel this. I mean, that it appears that these computers, there's these the ports on the outside aren't tied directly to an individual bus controller inside. There appears to be some fabric inside that switches the ports between bus controllers. And so we've had some interaction between if you plug in a USB 2 device into one of the blue jacks, it appears, although I haven't documented this, one should anticipate that it may have affect the capabilities of other ports.
Okay.
So
Are any of them explicitly identified as PD ports or
no,
delivery ports?
there's only one USB-C port on the front panel
Okay,
of the.
so
Okay,
that
so
would,
there's not. Okay, so that's the only
okay,
one there's only one of those.
okay.
And the others are all USB A style port.
Uh-huh. Well, A works fine for my purposes.
Okay, well,
But
anyway,
at
but
least,
it needs it, but I think our hope is that this is the magnetometer interface board you designed.
yeah.
So we just need to ensure that you will need to ensure that it's compatible with at least one 888 running on the same host.
I
I don't doubt it can be, but I'm just,
can't see why that would be any issue.
I've had
Unless,
many customer support calls. So I plugged it in and it doesn't run. So I log on to the computer and see that the 888's running on a port that's 460. I mean, for USB 2 speed. So
yeah,
I'll tell them, okay, go just replug the 888. replugs it into the same jack, and it switches to a different bus controller and goes to 5G, 5 gigahertz.
Well, that is
So,
the only thing at this point that I'm kind of concerned about is that kind of interaction. And I haven't had a chance to test that.
well,
But
you're right to be concerned,
yeah,
because it's and one of the things that we one of the problems we're having is that the 888 has been getting into a locked up condition, and we have the condition from which you can recover only with a replug or power cycle.
yeah. Well,
And Scott, as I understand it, you have an image file. You told me it's in you checked into GitHub that includes a watchdog that runs on the FX3.
Yes,
And
but it is not part of the stock Radio D distribution.
yes, so but I could, just as I've added and I still add your PCM record into.
Yeah, certainly.
Okay. I could add this image file as one more thing that Whisper Demon would add to the Radio D directory. I don't know where that image file goes, so it must go.
I put that in Signal. It's like user local share K9Q radio. It's easy to find. I can help you with that.
Yeah, well,
And
I don't know
it,
I don't know that Phil has a way to select between image files, so it would be.
he does.
Does he? Oh,
Yep,
good.
absolutely.
Okay. I didn't.
So
I'd never.
you can have it named by Watchdog 20 seconds or Watchdog 120 seconds, whatever, and then it
Oh,
would
I
be
see.
in
I
the
know.
radio
I'm not sure.
config
I don't.
file.
Okay.
Yeah.
I saw you had named many of them. I didn't know that if it was possible. I guess in radio D .conf there's a way to specify the image file.
There is.
Okay.
There is. It's in the 888 section. Yep.
Okay. I never. I just skip over that because I never had interacted with it before. So I
I've
can
been
have.
hesitant to add that, to push Phil to add that to the standard Radio D distribution, but talking to you now, I realize since you can specify the firmware image name, there's no reason not to add those. And then if
Yeah.
someone wanted to try it, all they would have to do is change the config file. It wouldn't break an existing system. It would be an addition.
Yeah. Well, I will be installing those as I will add them to my installation, and then make it possible in the whisperdemon.conf file to specify one of your watchdog image files. And so that way we can start by just turning that on and using your watchdogs selectively at places like Glenn's and elsewhere. And then later on, if it becomes clear that that's a more reliable or no less reliable than the current way, then I'd make it one of them the default. That's typically the way I go through deployment of software deployment, make things. Generally, I make them optional and then go on and eventually make them the default. So. Okay. Well, thanks for your work on that, because I think it's important. We do have I guess Glenn has encountered that lockup condition.
Well, you
And
need to thank Clint, because I believe it was originally his idea that I stole on that.
Well, it's I didn't. Is there a little watchdog processor in the FX3? Is it?
Yes.
Well, there is a similar watchdog processor inside the AMD, and I think there is probably in the Intel processors too. But I haven't seen a reason to turn those on. I have not. I mean, the times I've had a B-Link locked up, I could still ping it, which means that the watchdog probably would still think the host is alive, because if the host will respond to pings, something's running,
But
Well,
and
there are knobs you can turn so that you can say if the load average is above this, or if there's less than this free memory, or if the temperature goes over that, or if this
yeah,
host is unreachable, or if this process
well,
dies.
I think yeah, well
But
that's
until you know exactly what the problem is when it ends up in that state, it's hard to know if it would help or not.
yeah. I mean that the symptom was I couldn't SSH into the processor, and of course
It's
it
kind of,
wasn't doing anything. So I don't
yeah,
think I don't know that the watchdogs, the CPU watchdog, has the ability to test to see if it can SSH to the host. That requires a protocol stack in the watchdog that I don't know if it's there. So I don't know. It's a very low priority problem for me. But the locked up triple eights are high, not super high because I don't see them a lot, but they do. It does happen. And I mean, it happened to me today with Jerry in London. I had to tell him to replug his triple eight. So it's yeah. I don't know that your watchdog would have solved the problem. You know, I don't know. That's but you know, I'm inclined to try it and include it because I am seeing it, and especially things that are going to remote sites. I mean, I at the remote sites, and this Nathaniel, I think ought to be part of this site equipment list, is we do need remote control of the whole power, be able to power switch, cycle the power to
Yeah.
everything out.
Yeah.
And I don't know how to do that short of you know, short of having a you know a Wi-Fi access point, or you know, you have to be able to talk to you know, the
Right.
equipment outside of it. Uh, oh, there was one other issue out at WWV, which is internet connectivity.
Hmm.
I'm just aghast that our host out there is spending $120 a month for his wireless broadband internet connection.
That's how much I'm paying.
Ah, to your local ISP?
No, to Starlink.
Well, Starlink, he's not paying that to Starlink. He's paying it to a broadband, you know, fixed wireless provider.
Yeah.
I charge my users in Maui. I charge them $49.95, you know, a month,
Yeah.
and unlimited whatever you can get.
Yeah.
And I guess I'm not so engaged in today's economy. I'm somewhat insulated from the effects of inflation, but uh, that seems anyway. I'm a little concerned about us abusing the uh, you know, the hospitality out there.
Yeah.
And so one thought I had was I have a I can you can I stick my old iPhone, uh, tether it on it, and I get a perfectly good connection. I get for $15 a month, I get a 32 gigabyte unlimited, you know, unlimited for 32 speeds for 32 gigs, and then reduced speeds beyond that. But I don't think we come close to using 32 gigs a month.
I don't
So,
think so. I
actually,
mean, right.
I've measured it out at WWV. I think we've been using um,
I mean,
we've been yeah.
right now, the way the RX triplets are configured, we're uploading 30 megabytes a day, and then for just the WWV, and then if you include all the WhisperNet data, that's like almost nothing. You know, if you say 35 megs a day, you're probably being conservative. You multiply
I think
that, so
yeah,
you're talking about a gig a month.
yeah, yeah. So that seems to me to be you know,
Yeah.
it seems to me that anyway, I was thinking I might include this phone and ship it out with this uh, as if only as a way to try and see if it's as an alternative, see how well it works.
Yeah.
Because we may encounter other DAISY sites where this
connectivity and liability issues. Would argue for this kind of connection. And
Yeah.
I don't know to what extent I'd be violating the Verizon's terms of service by, this basically phone becomes a data only phone.
Right.
And it's not really getting any phone calls. So anyway, that's another experiment that's, I'm working a lot on security issues right now for the system that to increase, to kind of go to do the same things that the Bill Anko-Keys and the guys at University of Alabama doing.
Yeah. Oh.
Okay,
right.
well, those are my subjects. I think the key one is I'm not gonna go there, and we're not gonna do an antenna. We'll wait for a later time, and just get the timing thing. Focus on that, which is really the most important thing.
I agree with that.
For our project.
I agree with that.
So anyway, I don't know if you noticed, but your Jenny Jumps system
Is doing really well.
We're doing really well. I put up, I think I said, did I say last week, I put up a
5 milliwatts.
5 milliwatts, and Jenny Jump heard it.
Yeah, that was impressive.
On 22 meters.
That was very impressive.
I was really impressed until I got a report from Mark Jacobs in Australia. He heard me too.
Yeah.
So that was 14,000 kilometers on 5 milliwatts.
Yeah.
And but Glenn beat me because he put up 5 milliwatts in Fort Collins, and he got heard in Australia. So he's beat me now. He's a current champ. So anyway, okay. Anybody else have issues or questions? Clint, I don't know what's going on with your systems. Or Elmer, I haven't been logging onto your systems. I don't know what's going on with them.
All right, everyone. I need to go to bed.
Okay.
Thanks, everyone.
Okay. Good night.
Jonathan, I'll be in touch to talk to you more about. We'll talk about things more on Friday or throughout the week. Okay.
Okay.
Thanks,
sounds
everyone.
good.
Thank
Okay.
you.
Okay. So Elmer, what are you showing us there?
Oh, that was the first coil. I got the other one. I got to mount.